Okay, so many moons ago now, Damien gave a wonderful presentation on making C modules for MicroPython. So MicroPython's nice, we want it to run faster, how can we do that? We can write some C that we can run from MicroPython, keep our efficient parts efficient, keep the logical parts neat. You know, we can have that nice segregation. But Damien was explaining things really well, and it's really good, but as soon as he looked into the code, I was just like, oh, okay, and there's like 400 pieces of like random names that you need to know. Now that I've spent a bit of time with it, I realize it's not that bad, but as a beginner, you sort of, it's very confronting to have to know what you're trying to do and to know what you need to put in the right place. And the resources are there, but they're scattered around, and it's sort of look at what someone else has done and figure it out. It's not nice when you start trying to write it yourself. So what I've done, and in light of Matt's impending presentation on this particular topic in a couple of weeks at PyCon, check it out, I've written basically a simple web app that will generate the stubs, the skeleton code for your C function for you. So you tell it what type of inputs you want to have and what type of outputs you want to have, and it will put all of the guff around it so that you can just put your C logic that you know how to write and is normal stuff just in the middle, makes sense, and you don't need to know the details about the rest of it. You can just run it and it should do the job for you. I will note that it only does the basic cases at the moment. You want sort of integers and booleans and that sort of stuff, it'll do that. And B, there's a few other little bits that you've got to tweak to get it in there. There's a few other files you've got to add. I'm going to add some references to this so that you can get pointed towards them, but at the moment you've sort of got to know at least somewhat what's going to change and what you're going to do.
You're going to build on it.
I'm going to build on it. I'm going to get it there. I'm going to add lists at least as a type that you can put, but there's a bit of complexity there because, you know, Python's neat because you can have a list of anything. You can have a list of lists or a list of a list and then a string and then a list of strings, and that's happy. C is less neat about that, so how you interpret that gets a bit messy. But yeah, there's sort of pretty simple. You can change what type of output you want. You can change the names of things. You can set the number of inputs you want. And then, you know, it'll neatly generate all of the stuff that you want. So here's where the sort of functions initially set up. You've got, you know, it sets up all of your arguments that are in. If you want your arguments to have a different name, this could be the CCHS argument, and it'll neatly change the stuff. So then now you've got this Boolean value that you can just run and work with in your C code. And yeah, if you want to return integer called return value, then you know it'll set that up for you, and then you can just work with that and it'll return it. Then there's some mapping stuff you've got to do to actually get that function into Python, into the MicroPython. So you've got to sort of define it as an object, and then you've got to put that into your map. So that sort of gives you the template for doing that. There's still a bit of stuff you've got to work around in there, but I've tried to make it fairly self-explanatory and fairly easy so that you can just grab it, you put it in there, and you're off and running with it.
And so when you're calling this function from like the MicroPython mode, it just looks like a Python object. You call it with
exactly
booleans, lists, or whatever, and this handles all the translation and the casting.
Yeah. So once it's in there, yeah, it'll just look like MicroPython. You won't know, users won't know. You'll have suffered through a bit of the pain of writing the C to begin with, but yeah, it'll, from then on, it'll be neat. And it'll be faster, if you write it well. You can still write bad C. Language doesn't save you. But
how does an integer convert to a C type? Like, does it create a native integer? Is it signed? Is it unsigned?
Change it to integer type for one of the arguments to show how it works.
Yep.
It does work. So there you've got arg2 equals mp obj get int arg2 obj. So it turns that Python object into a native, like 32-bit signed integer. But so what will happen though is, because you can have really big numbers in Python,
Yeah.
and if it overflows, it will raise an exception.
Okay.
Say overflow cannot convert to machine word or something like this. Yeah. So because you could pass in a really large number to your function, and then your function just can't handle it, so it will have an exception, and it's just up to you to pass in small enough numbers.
So the presumption is that you'll write your C code to accept bool and int32, basically.
Yeah, so you'll write stuff.
So
Your
you're
C
not going to deal
code.
with int16s and things like that, odd integer types.
Yeah, so there are a lot of integer types. I've sort of put the basic ones in there that'll get you off and running.
Yeah.
I know there is like 64-bit ones.
Well, there's only really one integer type to get, and that's just on a 64-bit machine. It's 64-bit, but on a microcontroller, it's usually 32-bit.
Yeah.
And a 16-bit integer is just within the 32 bits, so there's nothing to do there. But you can write code that accepts arbitrary large numbers, but you have to operate on using like binary op add, binary op mul, because it could be a humongous number, 10 to the 100, and you want to add 1 to that, and you can't do that in C because it's too big. So you've got to just call you can in C. You've got to call more of the runtime to do all those operations. So you can do anything you want in C, operate on classes, on lists, on anything you like, but if you want to convert it to native types, like native integers, native floats, operate on the data and then convert it back, then you're restricted to what the native types are that you can manipulate. But if you've got floats or doubles, then there's not really any problems there because you can't have exceptions converting them. So if we're doing something like a Fourier transform, it would be really good, like this kind of thing work well.
Yeah. So this system is built for like getting the basic stuff. There's much more advanced stuff you can do. You'll need more knowledge associated with that. So that's getting outside of the scope. This is to get you started, get your feet wet, and dive in. Also worth noting that this is built off the backs of people that understand this. I'm not going to stand up here and pretend that I do. I understand the thing to generate the code. That's about sort of where my understanding goes. So hard questions. Damien's sort of given some great introduction to it, and I don't think anyone will know it better. And Matt's learning real quick. So
this kind of came about because one of the parts of my presentation that Python is going to be wrapping a C library. And this is perfect for that. Right? If you've got a C library that is full-featured and runs well, but you want it in MicroPython, well, generate the stubs to wrap it nicely. You can make that API look as nice as you like. There's good features in MicroPython to make it accept classes and lists and things like that. So from the Python side, it's great. You can deal with it in a really nice sort of API that takes in types as you expect, and then you deal with the conversions and the guff inside the C side. So Oliver was kind enough to throw this together, which has helped me a lot. So that's great.
Yep. And yeah, it's open source now as well. So
accepting pull requests if anyone wants to
accepting pull requests, yeah. Dictionaries, there's even stubs in there that I initially wrote in and then commented out as I thought, oh, that's going to be really
How
hard.
about passing strings through it?
Strings is an important one. I don't know how to do it.
Well, we can talk about
We can talk about
It's
that.
actually pretty easy. It's like, it would just be one function returning a const char start.
It'll be implemented at the end of the line.
It's just as easy as a short float. It's not even nothing.
Yeah. Okay, so watch this space for lists and strings. Yeah, cool. Thank you.
Yeah.